Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Chapter name Vector Analysis. Topic name Introduction to Electromagnetic Field Theory. Hello everyone. I welcome all the viewers of this video on electromagnetic field theory. This video is the first from the series of lectures for the course Electromagnetic Field Theory aimed at engineering students at undergraduate level. In this first video lecture, I will like to bring before you the points: what is electromagnetic field, the inspirations behind electromagnetic field theory, why we should be studying this subject, and the broad themes that we are going to follow in the entire duration of this course. So the first point, what is electromagnetic field? Electromagnetic field is the physical field produced by charged particles. As we see the term electromagnetic, it has two parts, electric and magnetic. See, the term can be split into two fields, electric field and magnetic field. Electric field is produced because of static charges, whereas the magnetic field is produced because of the charges moving, what we exactly called as current. As the cause for both electric field and magnetic field is same, it is necessary to study both the fields together. We term electromagnetic field. Hence, electromagnetic field theory can be defined as the study of electric and magnetic field subject to the state of the source. Till now, if we hear the word electric field, the scenario before us is that there it is a certain charge, whether the charge may be positive or negative, and the region influenced because of that particular charge, we call that region as electric field. In this diagram, we see the two charges denoted by positive Q and negative Q. The lines, what we term as electric flux lines, are always going away from the positive charge, whereas in the case of negative charge, these lines are always coming towards it. So a note can be done that the electric flux lines are always generated on positive charge, whereas they end on negative charge. Okay. So this is a general representation or general understanding of electric field. Now, regarding magnetic field, always the picture comes into the mind is that of bar magnet. In this diagram, a bar magnet having two poles, north and south, is shown. The bar magnet is also surrounded by some lines, what we call magnetic flux lines. Here also, the magnetic flux lines always originate at the north pole and they end upon the south pole. Now, in case of charged particles, okay, the charge in static condition we say produces electric field, whereas when it is in dynamic condition, when it is in motion, we say it is flow of current. So, if we have a conductor flowing current in particular direction, so that conductor will be surrounded by the magnetic flux lines. In this diagram, upright conductor is shown, the current in the upward direction, it is surrounded by the magnetic flux lines. The orientation of magnetic flux lines is always determined according to the right hand thumb rule. Thumb in the direction of current and the curled fingers gives you the direction of magnetic flux. Now, these two examples has given us the scenario of electric field and magnetic field separately. Now, electromagnetic field together, the common example we have is electromagnetic wave. The light what we get from sun or from any source is basically electromagnetic wave. So let us see electromagnetic wave. This is the diagram where the representation of electromagnetic wave, simply EM wave, is shown in three-dimensional space. Here, the coordinate axes are three and that are mutually perpendicular to each other. Electric field varies in this diagram in vertical plane, whereas magnetic field varies in the horizontal plane. The third direction shown by this axis gives you the direction of propagation of wave. Now let us focus on to the second point. What are the inspirations behind the research and development in the field of electromagnetic field theory? See, electromagnetic field is the fundamental force in the nature, like gravitational force. Whatever the naturally happening processes we see which transform energy from one form to another form, these I feel is the biggest inspiration behind the research and development, rather the curiosity developed by the scientists in this domain. Okay. The example is lightning. 19th century, the experiments resulting into the experience of magnetic field surrounded to the electricity and such similar experiences have given the direction to the scientists like Faraday, Ampere, Maxwell, Thomson, Green and Hertz to work consistently into this field. Now let us talk about the next point, why we should be studying this subject, electromagnetic field theory. The first reason is electromagnetic field is all around us. The second one, all the electric or electronic devices what we use. For example, if you switch on any device or if we press a key onto the keyboard, electromagnetic field comes into the role. The basic principle of all such devices is governed by four mathematical equations. I familiarly term it E mantras, which is known as Maxwell's equation. These are not only just four mathematical relations, but they have the complete summary of behavior of electric and magnetic field, which is responsible for the application to work. The next thing, the electromagnetic field theory, if the research and development in this area would not have been done, we would all have been in the dark ages. There would not be any kind of telecommunication or computer to work with and make ease of this work. Lastly, this subject is important for scoring university examinations, GATE examination, IES and other PSU examinations. So, learning this subject is very important. Now finally, we are going to see what are the broad themes of the subject electromagnetic field theory. The complete syllabus of electromagnetic field theory can be categorized into the following broad themes, that are namely vector analysis, electrostatics, steady magnetic fields, Maxwell's equations and time varying analysis, electromagnetic wave propagation through different media, radiation and basics of antenna. Most of the times engineering students find electromagnetic subject to be the killer subject, but I assure you the concepts in this particular subject are very simple to understand as compared to other engineering core subjects. Only the thing to get master into this subject is to have curiosity, motivation and consistent practice. Thank you.